Okay, so now that we know how to name and write chemical formulas for ionic and molecular or covalent compounds, we have all the basic steps that we need to write word and skeleton equations. So for this reaction here, it wants you to write the word equation and the skeleton equation. So for the word equation, you really just need to change some of these words reacts and forms into symbols. So it's beryllium chloride reacts with, we're going to indicate that by a plus, silver nitrate. There's not a lot of room in this, but to form, that we're going to indicate by an arrow. So this means yields, forms, produces. Beryllium nitrate and silver chloride. I'm going to have to go on another line. So plus silver chloride. So that is our word equation. Now to do our skeleton equation, we need to make chemical formulas out of these names, which we know how to do. We learned that in 4.1. So beryllium and chloride. But now we need to figure out the subscripts. So remember, what we do is we get our ion charges for each. So beryllium is 2 plus, and chlorine is 1 minus. And we do our crossover. And we get Be1 Cl2. Then we do our next one, silver nitrate. So I'll just write the symbols for now. So silver is Ag, and nitrate, if we remember, is NO3. And where did I get that? Nitrate is a polyatomic ion on the back of our periodic table, so NO3. Then we're going to write our, over here, our ion charges, so we can cross them over and get our formula. So Ag is 1 plus, and then nitrate, as we saw on the back, was 1 minus. Do our crossover, and then it just stays as AgNO3, right? Because both the subscripts are 1. Then we do our products, beryllium nitrate and silver chloride. So beryllium nitrate now, we write the symbols for beryllium and for nitrate. And then at the side here, we can just do our ion charges. Do our crossover to get our chemical formula. So Be1 and nitrate 2. So we need to put brackets and add a subscript of 2 there. And then our last product here is silver chloride. So write our symbols for silver and chlorine. And then over here we can just write our ion charges. They're both 1, so when we do the crossover, it's 1 to 1.